morning, students. We have already discussed the three types of reactions of aryl halides. The first one was nucleophilic substitution reaction. The second one, reaction of aryl halides with metals. And the third one is reduction of aryl halides. Today we will discuss the last type of reactions of aryl halides, that is electrophilic substitution reactions of aryl halides or haloarenes. Aryl halides such as chlorobenzene undergoes electrophilic substitution in the benzene ring, and this chlorobenzene or aryl halide will orient the incoming electrophile at the ortho or para position. So we say that Cl or the halogen is orthopara directing towards electrophilic substitution reactions. So the electrophilic substitution in haloarenes or aryl halides, in our case you may take it as chlorobenzene, takes place at the ortho and para position. Now this halogen atom present in the benzene ring, we know that chlorobenzene there, Cl atom is present in the benzene ring. If it is bromobenzene, then Br atom is present in the benzene ring. So halogen atoms present in the benzene ring is orthopara directing in nature. That means it will orient the incoming electrophile towards the ortho or the para position. Now we have to see that why this halogen atom in aryl halides is orthopara directing. We have already studied the resonating structures of chlorobenzene when I have discussed with you the low reactivity of chlorobenzene towards nucleophilic substitution reactions. You will find that all the resonating structures of chlorobenzene are shown in video 9. Now due to resonance, this chlorobenzene will show negative charge in the ortho and the para position. So in halogen benzene or in aryl halides, the electron density at the ortho and para position will be relatively more than that in the meta position. So electron density at the ortho and para position is increased. This is because of what? Because of resonance. Now, if at this position the electron density is increased, then the incoming electrophile will be attacked either at the ortho position or at the para position. For example, see this one. This Cl and here this chlorobenzene is orienting the incoming electrophile at the ortho position, and here the Cl is orienting the incoming electrophile at the para position. So halogen atom in aryl halide is orthopara directing in nature. This is because of the resonance. You will write this. Write that why halogen atom present in benzene ring is orthopara directing in nature. The electrophilic substitution reactions of chlorobenzene or aryl halides is much slower and takes place under drastic conditions when compared to that of benzene. Suppose if you were asked to compare the rate of electrophilic substitution of chlorobenzene with benzene, always remember the rate of electrophilic substitution of benzene is much greater than that of chlorobenzene. Why? What is the reason for that? Now in any aryl halides, let us take this as X. We have two effects. One is plus R, or we can also say plus M effect. So what is this plus R or plus M effect will do? This plus M effect will increase the electron density in the benzene ring. We have seen that due to resonance, negative charge occur at the ortho and para position. So due to plus R effect, or we can also say mesomeric effect, what happens? This effect increases the electron density in the benzene ring. Now this X is also having another effect, that is minus I effect, inductive effect. So because of this minus I effect, electrons will be drawn from the ring. So this effect will decrease the electron density of the benzene ring. So we can see that these two factors are acting in opposite direction, and here remember that in case of halogen, the minus I effect will be the predominating one. So as a result of this, these aryl halides will no doubt undergo electrophilic substitution under drastic condition, but this chlorobenzene or aryl halides are deactivating towards electrophilic substitution. So let us take the example of chlorobenzene. So chlorobenzene or any aryl halides, they are deactivating towards electrophilic substitution reaction. So if you were asked that why halogenobenzene or aryl halides are deactivating towards electrophilic substitution, in that case we have to say that this halogen in aryl halides, it has two types of effect. What are these? Plus M effect and minus I effect. So what is the function of this plus M effect? This plus M effect will increase the electron density in the benzene ring at the ortho and the para position. As a result of this chlorobenzene or aryl halides will undergo electrophilic substitution. But at the same time, this halogen is also having minus I effect. And this minus I effect, what it will do? It will decrease the electron density of the benzene ring, because minus I means it will withdraw the electron density from the ring. So these two factors are acting in opposite direction, and in case of halogen, the minus I effect will predominate rather than the plus M effect. So minus I is greater than that of plus M. So as a result of this aryl halides will become deactivating towards electrophilic substitution reaction. That means this chlorobenzene or aryl halides will not want to undergo electrophilic substitution reaction. It is reluctant towards electrophilic substitution reaction. But if the aryl halides, for example this chlorobenzene, is forced to undergo electrophilic substitution reaction, then the electrophilic substitution reaction will take place under drastic condition, and the halogenobenzene or the aryl halides will orient the incoming electrophile at the ortho and the para position. Now we will discuss some electrophilic reactions of halogenobenzene or aryl halides. Now let us discuss some of the electrophilic substitution reactions of halogenobenzene or aryl halides. Let us start with the first example of electrophilic substitution, that is halogenation. Halogenation. So here let us take aryl halides, for example, chlorobenzene. Now when we treat this chlorobenzene with chlorine in the presence of a Lewis acid, also known as halogen carrier, then this chlorobenzene will orient the Cl+, that is the electrophile, either in the ortho position or in the para position. So we will get a mixture of ortho-dichlorobenzene and para-dichlorobenzene. Now in this mixture, the para product will be major and the ortho product will be minor because of steric hindrance. Our second electrophilic substitution is nitration. So let us take this chlorobenzene. Now if you heat this aryl halides in the presence of concentrated nitric acid and concentrated sulfuric acid. So this chlorobenzene will orient the incoming electrophile. In this case, the incoming electrophile will be NO2+. So it will orient NO2+ ortho position and at the para position. This one. So this is the ortho product and this is the para product. Our third electrophilic substitution reaction is sulfonation. Now in sulfonation, which group is introduced here? In sulfonation, SO3H group will be introduced. Let us take this chlorobenzene. When chlorobenzene is heated with concentrated sulfuric acid, then we get a mixture of the ortho product and the para product. So this is orthochlorobenzene sulfonic acid and this one is parachlorobenzene sulfonic acid. Say this compound, when one H of benzene is replaced by this SO3H group, we call this compound as benzene sulfonic acid. So here Cl is ortho to this SO3H and here Cl is para to this SO3H. So its name is orthochlorobenzene sulfonic acid and this is parachlorobenzene sulfonic acid. Now our next electrophilic substitution is Friedel-Crafts reaction. Now this Friedel-Crafts reaction is an example of electrophilic substitution where we introduce either alkyl group or acyl group. So this Friedel-Crafts reaction are of two types. One is Friedel-Crafts alkylation. Another one is Friedel-Crafts acylation. Friedel-Crafts alkylation and Friedel-Crafts acylation. So first let us discuss this Friedel-Crafts alkylation. FC alkylation. So when you treat aryl halide, here chlorobenzene with alkyl halide methyl chloride in the presence of anhydrous AlCl3, then we will get orthochlorotoluene and parachlorotoluene. So this is Friedel-Crafts alkylation. Now, if I treat this chlorobenzene with CH3COCl in the presence of Lewis acid, anhydrous AlCl3, then the acyl group, that is CH3CO+, which is the electrophile here, will be oriented towards the ortho position and the para position, and we will get a mixture of this two product. Now we know that this compound, the name of this compound is acetophenone. So what will be the name of this compound? This will be orthochloroacetophenone and this will be parachloroacetophenone. And this is example of what? Friedel-Crafts acylation. Acyl group is introduced. And this is example of Friedel-Crafts alkylation. So with this we have finished the electrophilic substitution reactions of aryl halides. So we have discussed all the four reactions of aryl halides along with the preparation of aryl halides. In our next class, we will start a new chapter in organic chemistry, that is alcohols, phenols and ethers. Thank you very much. Have a nice day.